It'd be more of a joke and be funnier if I actually presented this the day before winter break, which is where this meme comes from. They're like, hey, let's start the next chapter. Or let's not start the next chapter because we just finished chapter 4. So we're not going to start chapter 5.
I thought we did chapter 5.
I know, the joke doesn't normally work, doesn't work as well. We're going to start chapter 6. I know, that's part of it. Fun is to put people in a tizzy. Also, it's a great word and I really appreciate it. So, today's question, what's the difference? 6.1. And I'm just very much a troll. I don't really have a bridge to live under, but I am just a troll. I'm a troll. I really appreciate being a troll. I'm working on my troll skills and leveling them up a little bit. Because sometimes I forget when I'm trolling and I start attacking people. I'm like, no, troll is the difference. You let them get all in a tizzy. I mean, I have a couple tables, so I guess I could be that. But if I'm going to be a really good troll, I should have a bridge to hide underneath and like eat goats as they come across.
What riddles would you tell people?
What riddles? See, that's the other part is that I have to figure that out. I'm not even sure what riddles I would tell. I got time, but I don't have a bridge, so I don't have the time. So I'm working on it. But I appreciate the looking up for me to make sure I've got all my bases covered. So we're going to find the area between two curves. So I want to find this area. How can I do that? This is how. With the definite integral. As we did back in chapter 4, definite integrals represent the exact area under a function between two values. Okay? Like, just to recap, that's what it is. Like, definite integrals have always been the exact area under a curve. When we first looked at them, we wanted to just write them and approximate them because we didn't have a technique to evaluate them all the time. But then a little bit later, we said, oh, we can evaluate in our definite integrals by using the fundamental theorem of calculus, which says, find the antiderivative of f, plug in b and a, and find the difference between the antiderivative of f of b and the antiderivative of f of a. That's how we do it. That's how we can exactly find that area in general. Cool. Yay! That's the exact area under the curve of f of x. Woo! We're pretty awesome. Good job, us. Ah! There's two functions. The area goes below the curve. What are we going to do? Yeah. Say it one more time.
Subtract?
Yep.
Whoa.
It's like the first thing I've ever gotten right.
Disagree, but we're going to go with that. I appreciate that. So if you didn't hear what Reagan shouted out a couple times, we're subtracting the two functions. Again, it works because f of x is greater than g of x over that entire interval. Oh, there's a little rectangle there. I've got a name for that rectangle. Yep. I'll wait. I've got a name for it. I'm not going to tell you the name yet. But notice that rectangle? It could be part of that region. It's not exactly part of the region. It doesn't fit very well. But it could be part of that region, right? In fact, you could say it's a rectangle. That's relatively representative of that region. This is where my joke's going. It's going to be either terrible or terrible with a couple extra L's in there because you just don't want to finish the word. To emphasize how bad it is. So, here's your newest representative, rectangle.
This is really bad.
It's really bad. I just made it this morning.
You made it this morning.
I made it this morning.
Maybe.
But this is my bad joke, but here it is. They're dedicated to representing the region they come from to help you understand how to accurately describe their constituents, aka the region.
I was going to say, what's constituents?
Constituents, well, it would be the people you represent. Ergo representative. Boom. And that's why we're like, our country is a democratic republic, because we elect representatives to vote on things democratically. Yes, it does. In fact, it's very rigid, but it should be a little less rigid to be an effective politician, to represent its people and constituents. But the more,
I know his joke is better than your entire presentation.
yeah, it totally was. I appreciated that. All right. But anyways, the idea is, if I go back to this representative rectangle right here represents a snapshot of the rest of its constituents, like all the other rectangles I could draw in there to try to represent the area. Because the height of this rectangle would be f of x minus g of x, which is how I can figure out what goes right here. So knowing representative rectangle is trying to help accurately describe their constituents. Ah! What about this?
What the deuce?
What the deuce?
Divide. Is that it?
It's not divide, but that's a good idea.
Multiply.
Also a good idea, but no.
Addition.
Yes.
Oh, we got there.
Eventually we got there.
Well, you need to like wait for like 30 minutes while I try to figure that out.
That's okay. We're eventually going to get there. So here we have, notice that this isn't a single integral that represents this region. It's one region, but it's described differently after a certain point. Notice how from A to B, here's A, here's B, it's f of x minus g of x. And we could draw in the representative rectangle in both of these spots to see that. The height here of rectangle is f of x minus g of x. But after this point B, the height of it is g of x minus f of x. Thanks, rectangle. So the idea that we're trying to lay out here is that when you're trying to find the area of a region between two curves, draw on a rectangle, draw on representative rectangle, and think about what's the height of this rectangle. Okay? Now we're going to focus on the width of the rectangle in the next several lessons. That's not the thing I care about today. But do note that the width of representative rectangle is in x, and that's why our variable down here is x, is dx here. If we had drawn rectangle a different way, like instead of vertically, drawn representative rectangle horizontally, then they would be representing in terms of y instead of x. So basically the idea here is that we can just write a couple different integrals to represent different regions. But that's it. I don't even have I do have a troll, but in this one, it's just showing you how to find the intersections of regions. So this, I encourage you to go to Schoology, find it and read through it if you're not super confident about how to find the regions and do all this on a calculator. I typed out the steps. I have an animated GIF for you on both slides here to go through that process. Okay. I encourage you to go take the time to look at it. I'll give you more time to talk through it and do it, but I'd rather you just kind of do it when you have the time. All right, here's your practice.
Oh, sure.
You legitimately can finish this by the time, or get pretty darn close. I put the due date as today, but that's maybe a little intense. I'll change it till tomorrow. But it is definitely due soon, very soon.
Tomorrow, I can't remember what the schedule was for this week. Is tomorrow another assignment or is it a work day?
Another short assignment. We're gonna take the next section and break it up instead of like 2 or 3 days, like probably 6 days. What's that?
When's the next work day?
It's a great question. I want to say it was Friday,
Oh,
but today's Wednesday. Yeah, I'm thinking Friday.
okay, perfect.
Or what'll happen is we're gonna do a bunch of short lessons. Like this, we're done with the lesson at 13 minutes into class.
Yeah.
So probably shorter lessons, longer work time.
Okay.
That's kind of what I think the next 5 days will be like. We're gonna do a bunch of short, like 10, 15-minute lessons, and then 35 minutes of work time.
I have a pencil.
don't have extras there? Yeah, sure.
One time, who made us give you a?
Yeah, who was that?
Oh my god.
You remember that?
Yeah, I remember that.
I was like, your student's gonna be.
Oh, you know who it was? It was Mr. Peeler.
Yes. Yeah.
Yeah, I missed that,
He
dude.
went
What
to
happened?
Brazil.
He's a cool guy.
There?
He moved to Brazil, yeah.
Oh, no, he didn't go to Brazil.
That was his initial plan. was to go
He did not go to Brazil. He went to Costa Rica. He
Costa
taught
Rica.
math in Costa Rica with his wife for a year.
Yeah.
What's that?
Then where did you go?
And then he's came back to start working for Microsoft, working as a rep for TEALS, which is a computer science program. And now he's working on getting a master's degree in data science.
This is a cool dude.
This is all about.
I like the way he's good.
Oh, I don't have any extra hardcore tape with me.
It was like,
Find some heavy glue and just try to shove
yeah, I
it
feel
in
like
there.
I really know those.
No, he like,
What about
why
duct
is
tape at
fancy?
home?
That's probably sufficient. Also.
Yeah.
Or just
And you're like,
be
where's
very
all the-
thoughtful of it.
well, it was hilarious.
I forgot about Mr. Peeler.
Yeah, he's a fun guy. I talk to him every now and then.
We had one freshman year.
They had a kid.
Yes, that was geometry.
So he's-
freshman year.
He's reproduced.
I missed Keely's.
Oh, that's right, Dan. That was
Eighth grade.
Yeah, you were in 8th grade, but
I forgot.
That's what I said, but like now that I remember him, I'm like, he was cool.
He's a cool guy.
I had Tealy science.
I'd say he's a fun guy, so I can say mushroom.
Were you the soccer coach?
Yes, he was also this, JV stuff.
Oh, that's right. Hey, virtual folks. I'm just gonna end this. You can come back in.